In this one, the highest order term is going to be 3, so there are going to be at most 3 real zeros. As far as the variations in sign, you have it goes from positive to negative here, and then negative to positive there. So there's 2 variations in the sign of f of x. Therefore, it's either going to have 2 or 0 positive real zeros. Remember, it's the number you get or that number minus an even integer. So in this case, our even integer is 2. So it's either going to be 2, the variation sign, or 2 minus 2, which is going to be 0. So you're either going to have 2 or 0 positive real zeros. Then you check f of negative x and see how many variations in sign that one has. It appears just to have 1 when this negative changes to positive, so it has 1 variation in sign, and therefore there is only 1 negative real zero. I think I wrote this out. There is 1 0 negative real 0. I don't think I need to say 0 there. It should be just say there is 1 negative real 0. Again, this is a function that has only integer coefficients, so you can use the rational zeros theorem to determine the potential rational zeros. In this case, you have to take the last term and the first coefficient, so that's 12 and negative 2. And 12 has a bunch of factors. It's going to be 12, 6, 4, 3, 2, or 1, all of them plus or minus. And as far as the 2 up here, the negative 2, it's going to have factors of plus or minus 2 or plus or minus 1. So then again, you figure all of these out. You're going to have either 12 over 2 or 12 over 1, 6 over 2, 6 over 1, 4 over 2, 4 over 1, 3 over 2, 3 over 1, 2 over 2, 2 over 1, and 1 over 1. Or you could also have 1 over 2, you can have 1/2 as well. So these are your, and they're all plus or minus, so these are all of your possible real zeros. Not all of them are going to be there, but these are the possible ones. And then step 4 was determining the bounds. So to do that, remember that you take the last term, all of the coefficients of the terms up to the you don't use the very first ones, but you use the 12, the 4, and the 5. Oh, and actually you have to factor out, when you do the step, because the first coefficient has to be 1, of the leading term it has to be 1, you have to factor out a 2 first. So you factor out the 2, and then you get this as the polynomial you're working with to determine the bounds. You use the 6, the 2, and the 5 over 2, but you don't use the first coefficient 1. So you write down those terms, and you need to find the maximum of either 1 or the maximum between 1 and all of the coefficients added up, again, except the first one. So you 5 over 2 plus 6, and the maximum of that is going to be 21 over 2. I calculated it out. And the other maximum is going to be 1 plus the largest term in here, and I guess that the largest one is 6. So that's the maximum of those terms, and you add 1 to that, and that's 7. So you take the smaller of those two numbers, and let me see, it looks like the smaller of them is going to be 7. 21 over 2 is greater than 7. So the bounds are going to be, the bound of zeros is going to be between negative 7 and 7. And I plotted the graph out using that bound for the x-axis. And we see we get a 0 here and a 0 there. It looks like that 0 is at negative 3/2. And it looks like this 0 is at 2. So again, it appears to have zeros at negative 3/2 and 2. You have to use the factor theorem to test that. So you put negative 3/2 and you put 2 into the original function we have and see if it works out to be 0. And I did it, and in fact, it does work out to be 0. And therefore, you know that x plus 3/2 and x minus 2 are going to be factors of x. Oh, and another thing to notice at the graph, remember it said we were going to have either 2 or 0 positive real zeros and 1 negative real zero. So as far as our positive real zeros, we actually, although it looks like we only have 1 0, actually we have 2 by this 2, because this bounces off the x-axis and goes the other way. So that means it's going to be, the 0 for this term is going to be of even multiplicity. So this one would be x minus 2, and that particular factor term is going to have to be of even multiplicity or squared to show that we end up with 2 positive real zeros, which we said we were going to have. We were either going to have 2 or 0, but we can't just have 1. We have to have 2. If we don't have 0, we have to have 2. So although only 1 is shown, actually that accounts for 2 of the factors because the term is squared. So when you write out the factors, you put back in the 2 that we kind of factored out up here. So one of your factors is going to be 2 anyway, and then you put in the 0 terms that you found, and that one of them is x plus 3 over half, so we put that there, and the other one is x minus 2, and since it's of even multiplicity, you have to put the square there. So when you write f of x in factored form, it turns out to be this, and if you expand this all out, you'll see that you get your original polynomial. So I might just leave the other 2 for you just to look at and read through, because they're more or less done in the same way. If you have any questions about them, just send me an email. But I think that's enough to complete the discussion on this part of the homework.